Today, we are diving into a story that honestly sounds like it's pulled straight from science fiction. It's about a tiny, practically unknown AI model that did something that really challenges the biggest names in the industry. It's hinting at a huge shift in how we think about building intelligent machines.
So let's just ask the question right up front. Can a tiny AI actually beat a giant? I mean, it sounds completely impossible, right? But what if I told you a new model with only 27 million parameters is running circles around massive models from places like OpenAI when it comes to complex reasoning? The real question isn't if, it's how.
To get how this amazing feat is even possible, we first have to talk about a fundamental flaw, a kind of hidden weakness in how all the famous AI models, like ChatGPT, actually work. And understanding this changes everything.
And this really gets to the core of it. See, true reasoning is logical. It follows a step-by-step path to figure out an answer with some certainty. But that is not what today's large language models do. They're prediction machines. They look at what you type, and based on a mind-boggling amount of data, they make a very, very educated guess about what word should come next. It's a pattern-matching game, not real logic. And listen, this isn't just some fringe theory. The AI pioneer Jan LeCun said it perfectly. Just because a machine can imitate human language doesn't mean it can think like a human. Looking smart and actually reasoning are two very different things. So what does this actually look like? Well, if you ask a standard model a math problem, like what's 27 times 25, it doesn't grab a calculator. It just predicts the next most likely character. In this case, you can see it gives a 38% chance that the answer starts with a 0. It's not calculating, it's just guessing based on patterns. If it gets the right answer, it's likely just because it saw that exact problem in its training data and memorized it. Right about now, you're probably thinking, hold on, what about chain of thought prompting? Where you ask the AI to show its work. Well, the researchers behind this new model would say that's basically just a patch. It's a clever workaround that makes the model look like it's reasoning, but it doesn't actually fix the fundamental problem with its architecture. So if the current way of doing things is broken, where do you look for a better solution? Well, these researchers looked for inspiration from the most powerful and efficient reasoning machine known to exist, the human brain. Our brain works in a hierarchy. Think of it like this. You've got a high-level system, kind of like the CEO in your prefrontal cortex. It's slow, it's strategic, it thinks about the big picture. And then you have a low-level system with super fast neurons that handle all the immediate details and actions. The high-level guides the low-level, and the low-level does the work and reports back. So the big question is, how do you build that brain-like structure into an AI? Well, these researchers designed a brand new architecture specifically to mimic it, and they call it the hierarchical reasoning model, or HRM. The way the HRM works is explained with this brilliant analogy. It has two parts. The high module is the architect. It's slow, it's strategic, and it lays out the master plan. The low module is the engineer. It's fast, it's tactical, and its job is to execute the details of that plan. This teamwork is what makes it so powerful and efficient. And here's how they work together in this really smart cycle. The architect doesn't micromanage the engineer. Instead, it creates the plan. The engineer gets to work, building one phase. Then, the architect checks in, reviews the progress, and updates the plan if necessary. Then the cycle just repeats. It's a super efficient feedback loop. Now, this structure gives the HRM some huge advantages. First, its memory is way more efficient because it's only tracking the high-level plan. It also learns from mistakes at every single step, not just at the very end. That's called deep supervision. And what's really cool is it knows when to stop thinking. It's called adaptive computation. It knows when the problem is solved, so it doesn't waste energy, which is a massive issue for older networks. Okay, so the theory sounds fantastic, but does it actually work in practice? Let's take a look at the results, because honestly, they're pretty staggering. This is the size of the hierarchical reasoning model, 27 million parameters. That's it. Just burn that number into your brain for a second. Now look at this. This is what our 27 million looks like next to something like GPT-3, which has 1,750 times billion parameters. The HRMI is thousands of times smaller. That's not a small difference. It's like comparing a go-kart to an aircraft carrier. So what can this little go-kart of a model do? Oh, not much. Just solve complex Sudokus, navigate mazes, and yeah, it outperforms GPT-3 on key reasoning benchmarks. And get this, it was trained on just 1,000 examples, not billions. 1,000. This just proves that a smarter architecture can absolutely crush brute force and massive data.
Now, before we get too ahead of ourselves, the authors themselves add a very healthy dose of scientific humility. They make it clear that while their model acts in a way that's very similar to the brain, it's a correlation. They haven't proven it's the exact same cause, but wow, it is one heck of a strong hint that they're onto something big. So what does this all mean? The big takeaway here is that we might be looking at something more than just a new, clever model. This could be a whole new path forward, a more efficient, more brain-like path to creating machines that can actually reason, not just predict. So, are we standing on the edge of a brand new era for AI? It's really starting to look that way.